Okay, back to creationism versus evolution. K55.htm. There you go. We're about in the middle of that. We now want to look for this phrase. In view of the fact that fairly low retentivities sometimes occur, even in the case of mica, that's talking about age dating methods. In this case, potassium-argon method. Let me go back up and look at it. The potassium-argon method. Radioactive potassium releases argon gas and goes back to a non-radioactive element. So, in view of the fact that fairly low retentivities sometimes occur, even in the case of mica where potassium is in there, measurement of the potassium-argon age of mica does not give a completely trustworthy value of the age. In other words, the argon gas released in from the potassium, radioactive potassium, most of the time escapes. It's the gas. Thus, as we examine one by one the various radioactivity methods for measuring geologic age, we find that each encounters many serious problems in its use, enough to cast grave doubt on the reliability of any age computed from it. The potassium-calcium method, similar, is even less reliable than the potassium-argon because, owing to the fact that radiogenic calcium of atomic weight 40 is impossible to distinguish from other calcium-40, which is commonly found and present in potassium minerals. Not everything is radioactive, so calcium-40, we don't know whether it's radioactive or not. It's impossible to detect. Hunt says, unfortunately, calcium-40 is the most frequent partner of the regular mixed element calcium. Therefore, only in very old potassium minerals, nearly completely free of calcium, is it possible to find, through extremely accurate mass spectroscopy, the very small shift in the isotope ratio of calcium, and thus the activity of the potassium for age determination. So, Dr. Don Patton, in this great resource that I have discovered from him, notice the statement by Joan Engels of the Journal of Geology, talking about the potassium-argon method. She says it is now well known that potassium-argon ages obtained from different minerals in a single rock, not around the world, may be strikingly discordant. 2 inches away. No good. In other words, they do not agree. Likewise, we noticed a statement in Science magazine recently regarding lavas from a volcano in Hawaii, and we're told that the radiogenic argon and the helium contents of 3 basalts erupted into the deep ocean from an active volcano, Kilauea, have been measured. Ages calculated from these measurements increase with simple sample depth. Wow. Now, this is one eruption, one formation, but the ages increase with sample depth. It erupted and ran over the edge into the ocean. Up to 22 million years for lavas deduced to be recent. It is possible to deduce that these lavas are very young, probably less than 200 years old. There's a little difference there. 22 million over here, 200 years over there. The samples, in fact, may be very recent. We're there all the time. Now it increases with sample depth. We also know that pressures increase with sample depth. They're actually measuring the argon, which is rather abundant in the Earth's atmosphere. If that atmospheric argon is incorporated into the rock, which is possible, then it's going to skew the results. Then obviously it's going to skew the ages. They're assuming it all came from radioactive decay. Big assumption. But if it is included from the atmosphere, then it throws it off. But the fact is that it increases with sample depth. And so does the atmospheric argon because of greater pressures. The further down you get, the more pressure, the more argon is going to be forced into the rock, so the greater age. It's nothing to do with age, it has to do with the sample depth. We can see what's happening here. You're just incorporating atmospheric argon into the sample, and you're not producing a dependable date at all. Now, this is so obvious. A novice like myself, I'm not even close to being scientific, can say, well, this doesn't make any sense. I don't trust anything these guys say. If they do this, what else that we don't know about? You know, you have to read in depth their writings, all of them, which you won't have access to, which they're not going to give you. So I have to go with what I can trust, and I can't trust them at all. Excess argon, the Achilles heel of potassium-argon and argon-argon dating of volcanic rocks. Dr. Andrew Snelling, he's a believer, scientist as well. For more than 3 decades, potassium-argon and argon-argon dating of rocks has been crucial in underpinning the billions of years for Earth history, claimed by evolutionists. Critical to these dating methods is the assumption that there was no radiogenic argon in the rocks, the basalt, when they formed. Okay, how do you know that? Were you there? Which is usually stated as self-evident. Dalrymple argues strongly that potassium-argon method is the only decay scheme that we can be used with little or no concern for the initial presence of the daughter isotope. Vote for me for president. This is because argon-40 is an inert gas that does not combine chemically with any other element and so escapes easily from rocks when they are heated. Thus, while a rock is molten, the argon-40 formed by the decay of K40 escapes from the liquid. Okay. However, this dogmatic statement is inconsistent even with even Dalrymple's own work, which he worked on 25 years earlier, and then makes a statement 25 years later, on 26 historic subaerial lava flows, 20% of which he found had non-zero concentrations of argon-40, or excess argon, in violation of this key assumption of the potassium-argon dating method. The historically dated flows and their ages were as follows, and this writer puts it out there. All these different, 25 of them, vary so considerably. Other studies have also reported measurements of excess argon-40 lavas. The June 30, 1954 andesite flow from the Mount Nugari-Hoi in New Zealand has yielded ages, so-called ages, up to 3.5 million years ago due to excess argon. Austin investigated the 1986 descent lava flow, Mount St. Helens, a million years due to excess argon. Concentrates of constituent minerals yielded ages up to 2.8 plus or minus 0.6 million years. Wow. Investigators have found that excess argon-40 is trapped in the minerals within lava flows. Several instances have been reported of phenocrysts with potassium argon ages 1 to 7 million years greater than that of the whole rock, and so the rock over here, less, 1.7 million, 1 to 7 million years less. Over here, more. Really, the same rock? Laboratory experiments have tested the solubility of argon in synthetic basalt melts and their constituent minerals, with olivine retaining so much. It was concluded that argon is held primarily in lattice vacancy defects within the minerals. So here's the obvious conclusion. Most investigators have reached is that the excess argon-40 had to be present in the molten lavas when extruded. When they did not completely they dig us as they cooled, the excess argon became entrapped in constituent minerals and the rock fabrics themselves. However, from whence comes the excess argon, that is, argon-40, which cannot be attributed to atmospheric argon or in situ radioactive decay in potassium, It is not simply magmatic argon. Funkhauser and Norton found that the excess argon-40 in the Honolulu flow, Hawaii, resided in fluid and gaseous inclusions in olivine, plagiaulus glass, and pyroxene, and ultimate xenoliths in the basalt, and was sufficient to yield ages, fake ages, 2.6 million to 2960 million years. Wow, really? Okay. Thus, since the ultramafic xenoliths and the basaltic magmas came from the mantle, the excess argon-40 must initially reside there to be transported to the Earth's surface in the magmas. What does all this mean? Technical stuff. Many recent studies confirm the mantle source of excess argon-40. Hawaiian volcanism is typically cited as resulting from a mantle plume. Most investigators now conceding that excess argon-40 in the lavas, including those from the lava Lohi and Kilauea volcanoes, is indicative of the mantle source area from which the magmas came. Considerable excess argon-40 was measured in ultramafic mantle and xenoliths from Kerguelen archipelago. In the southern Indian Ocean, likewise, is regarded as the mantle source signature of hotspot volcanism. Indeed, data from the single vesicles in mid-ocean ridge basalt samples dredged from the North American suggest the excess argon-40 in the upper mantle may be almost double previous estimates, that is, almost 150 times more than the atmospheric content. Another study of the samples indicates that the upper mantle of argon-40 could even be 10 times. Wow. Yet they still maintain. Further confirmation comes from diamonds, which form in the mantle and are carried by explosive volcanism into the upper crust and to the excess. So when you're in the crust, it doesn't matter. The age depends upon what happens below the crust, not how old it is. When Zashu obtained a potassium-argon isochron age of 6 plus or minus 0.3 billion years ago, I don't know, for 10 Zaire diamonds, it was obvious excess AR40 was responsible because the diamonds could not be older than the Earth itself. See, it's so great. These same diamonds produce argon-40 yielding 5.7 GA isochron. Is that giga years or something? It was concluded the argon-40 was an excess component which has no age significance and is found in tiny inclusions of mantle-derived fluid. The argon was inside the mantle. All this evidence clearly shows that excess argon-40 is ubiquitous in volcanic rocks, indeterminate, and that the excess AR40 was inherited from the mantle sources, the areas of the magmas, before it came out of the crust. So it didn't sit out on the crust of the Earth for millions of years. It was already had that much argon in it. This is not only true for recent and young volcanoes, but for ancient volcanics such as the Middle Proterozoic Cardenas basalt of eastern Grand Canyon, as that's their so-called ages. In the mantle, this argon-40 predominantly represents primordial argon that is not derived from in situ radioactive decay of K40 and thus has no age significance. On and on and on. In conclusion, the fact that all primordial argon has not been released yet from the Earth's deep interior is consistent with a young Earth. Comes out there and start measuring stuff. That was originally came with the sample. Didn't sit there and start to deteriorate. Also, when samples of volcanic rocks are analyzed from potassium-argon and argon-argon dating, the investigators can never really be sure. Therefore, whatever AR40 is in the rocks is from the in situ radioactive decay of K40 since their formation. Or did it come from the mantle? Yeah. Or whether some of it all came from the mantle with the magmas. Original. This could not even be the case. This could even be the case with potassium-argon and argon-argon analyses yield dates compatible with other isotopic dating systems. It's just coincidental and or with fossil dating based on evolutionary assumptions. 3 compounding errors. Furthermore, there would be no way of knowing, because the argon-40 was from radioactive decay of K40, cannot be distinguished analytically from primordial argon-40 coming from the original argon, not from radioactive decay, except, of course, by external assumptions about the ages of the rocks. Well, we know the ages of the rocks are dependent upon the ages of the fossils, are dependent on the ages of the rate